Slide says, I'm Clay Jackson from Quest Software. Been doing Oracle for a long time before that. Before I came to Quest, I was a customer in a lot of different places in the Northwest. I'm from the Seattle area, so a lot of good things up there. And yes, at one point I did work for Microsoft way back. About the only place I didn't go was Boeing. Never had a chance to get to Boeing. How many here in the room are DBAs? Great, okay. How many people are using DevOps or have dabbled in DevOps? Oh, that's good. That's more people than we normally get. Okay. Well, this talk is going to be about DevOps and so sort of an introduction to DevOps, where it came from, what it is, and how DBAs and database developers might use it to help their companies out and make some things happen. Because we are a sponsor, I get a little bit of commercial at the end, and so I'll warn you when that's coming, but try to keep it technical and keep the marketing stuff out of it here as much as I can. So what are we going to talk about? What is DevOps, where did it come from, why it's important, and why it's more than just the latest big trend. Some DevOps definitions, which is really going to be the meat of talk. And then as a DBA and developer, what's in it for me, and some tools, and that's where we'll kind of get into the commercial. I'll warn you before that's coming. So, okay, so what is DevOps? DevOps kind of started out with Gene Kim and Kevin Bear and Gene Spafford. They wrote a book called The Phoenix Project. If you haven't read that, how many people read The Phoenix Project? Okay, if you haven't, pick it up. It's on Amazon. You can download it for Kindles, all sorts of things. It's a quick read and very informative. Talks a little bit about why DevOps is important and some of the principles they came up with. They first of all talked about visible ops and some other things, but go ahead and pick that up. That's kind of the DevOps Bible. So in a nutshell, DevOps is this intersection here between development, software engineering, QA, quality assurance, and testing, and operations. And the whole idea is that by putting developers in the middle of operations and making them responsible for what they eat, eating their own dog food, as they say at Microsoft, we're able to get things done faster, more efficiently, and work a lot nicer and a lot better. Anybody here from Amazon in the room? Okay. How often do you guys drop code these days? What's the latest? Yeah, pretty quick. The last statistic I heard was once every 15 minutes, there's code dropped somewhere in Amazon, and I think it's probably faster than that now. And they're big DevOps users. I've got a number of friends that work there, and one particular guy in a web development group, and every 6 weeks, their entire group rotates over and starts answering phones on an internal helpline. So Amazon has really embraced it and really set it up and done it, and you know, you can all see the results on that. So 3 Ways DevOps by Gene Kim. I want to start system thinking. Now, a lot of us have been doing that for a long time anyway. Particularly, you guys here at this conference, you're here because you're thinking outside the box and thinking about things differently than Oracle or the Amazon or the marketers do. But it's not quite out in the rest of the world yet. As I said, we're still getting. I'll go into a room like this full of people, and I meet people who use DevOps, and I'll get maybe one person to raise their hand. So you guys are already ahead of the curve. Anyway, what I want to do is break down silos, break down those walls and those barriers between the different organizations, so that you don't have developers developing code and throwing it over a wall at the DBAs and then saying, "Okay, go make this work." I set feedback loops up so you get closer to your customer and you get good feedback going between your customer, whoever that is, either internal or external, and your users. And we want to have a culture of experimentation and learning. You can't get a hit if you don't swing, right? If you're so afraid that you're going to break something, you're going to choose something, you've got horrendous change control processes that take 2 weeks or whatever. Well, you're not going to be able to get products out the door very quickly. You're not going to be able to get things done and not be able to make any motions toward innovation and things like that. So it's very important that you have that culture. And in fact, a lot of this stuff I'm talking about today isn't really technical in nature. It's more about cultural changes and making differences in organizations where you can make something happen and make changes to an organization. So why DevOps? Okay, adopting DevOps, you're going to get some increases in speed with shorter development cycles and continuous delivery. And I'll define these terms again in a little bit, so talk about what they mean and why and how DevOps can increase speed of development. Communications and collaboration, looking at team performance and continuous integration. One quick story I'll tell about that. When I was in a large major bank based in Seattle, word came down that thou shalt outsource. We had to outsource basically 50% of our IT budget went to outsourcing in the space of about 6 months. They made that change to us. And a lot of departments were having all sorts of trouble making that happen. We had a security organization that gave them 6 months to outsource the generation of logins and passwords and provisioning users. And they did that by coming in one day and getting security people together and saying, okay, 6 months, you have 50% of you going to be gone. Start training your outsourcing counterparts and start making things happen. 6 months came and left. They pulled the switch, and now all of a sudden provisioning a user went from 20 minutes or an hour to 2 or 3 days because they hadn't done a good job of training their replacements. The group I was in took a little bit different approach to it, and one of the first things we did is did a lot of hiring freezes, so we weren't hiring new people only to have them get laid off. We wound up laying off about 3 people out of a staff of 28, so we didn't cut down to 50%, but we did increase our services. And one of the things we did that was very critical to that, I think, was we went to our existing DBAs and we said, okay, look, you guys are going to have to outsource a lot of your routine processes, things like creating databases, things like doing that. So we're going to change your compensation model a little bit. We had a 15% compensation was based on objectives and bonuses, and the other 85% was fixed salary. We said, okay, of this 15% bonus you're going to get, you're going to have to write a process improvement document and document a process or improve a process. And if you write or improve 2 processes during the year, you get a 3, you get mid of the road on your bonus. If you write or improve more, you get more, and so on. And lo and behold, by just changing that, we had a bunch of DBAs say, hey, that's a good idea. I'm going to do that to not only make more money, but also keep my job and stay in good. And we managed to build a team of our outsourced folks, and we won several awards in our group and also for the company in terms of successfully outsourcing as opposed to outsourcing debacles a lot of people have seen and having to bring that stuff back on shore. So there's some things you can do there with communication and collaboration that really make a difference. And also, you get what you pay for behind that story. And then finally, the last thing DevOps is going to increase is your efficiency because it's going to build scalable infrastructure, okay? DevOps is going to decrease development time, much shorter cycles. You're working on smaller pieces of code, smaller things that only do one thing, modules that only do one thing. It's going to be a lot faster to develop those and work those. And it's going to decrease failures. Your deployment's going to go faster. Your time to deployment's going to go faster. And if you've done it right, your time to recover is going to go faster because your recovery can be automatic. And most of the time, unless you're being very conscious about it, you're not going to be changing fundamental things. You're changing little incremental things. And we'll talk about that again in a few minutes. And you're going to decrease costs, right? Less IT staff, or your IT staff is going to be more productive. So you're not going to be having to hire more IT staff. And you've got less overhead. So you can take a look at that. So let's look a little bit about some challenges of database development, right? Here's a situation. We got application development on top and DBAs on the bottom. When we start out, and the application developers on top, they have Bamboo and maybe Jenkins and a bunch of things. And so they build their test environment. They're doing all continuous integration. And then, oops, great big yield sign comes along. Now we have to go through the bottom there. DBAs have to build, test, release, and so on. And then finally, we get into our next environment there. We get into our QA environment and deploy, and then we go through the whole thing all over again when you get through that. Everybody's here has got their, at least their database code and everything else under source code and configuration management, right? Everybody's doing that. If you're not, think about it and do that. So some DevOps definitions. First one, the one I like here, kind of the figure 8. It's really a classification of what DevOps is like. We start with planning, coding, building, test, make a release, deploy the release, operate the release for a while, monitor it, figure out what's wrong, and then go back and go through that whole cycle again. Now, lots of different representations of this and the whole cycle in incident management. Some of those things we have the planning P that does basically the same thing, but I kind of like the figure 8. It kind of shows what goes on and what the flow is there. So again, it's iterative. We design, we write tests, we code, we test, and then we rinse and repeat that whole process. So Some DevOps definitions here. First one, test-driven development, right? Also known as design-driven. You design first. You want to design your application or your piece of code first, and then write some tests that are going to test that and make sure it does what you want it to. And let your designers write the test. Don't let the coders write the test. Now, coders are going to write some tests, of course. You're going to write assertions. You're going to write things like that. But don't let your coders write all the tests. Let your designers write the tests. And then again, it's very iterative. You design, you write your tests, you write some code. You test the code, see where it failed, and repeat. You go back and design changes. Write the tests again, you code, you test, and you repeat. And you do that forever, and you're working with small modules. That's a very easy way to get some things done. Okay, regression testing, that's the next one. Testing to be sure new features don't break, right? That's what you want to do, is make sure your new features don't break the rest of the code. You're going to add something and make sure you didn't do something that's going to break something else. Well, that's great, and it's also going to support continuous integration and continuous delivery that we'll talk about. But if you're going to do regression testing, it's got to be automated. It's got to be designed. It's got to be conscious. You've got to be thoughtful about it. You've got to be deliberate. And don't do what a lot of companies have done, including some places I've worked in the past, where all you do with regression testing is you build up a bunch of bugs and you test all those bugs. Well, you shot that bug. Why do you need to test for it again, right? You want to test for things that you don't think about, or things that are part of the design, not necessarily things that are part of whatever happened in the past. You know, if you've fixed a case where you've got a buffer overflow and you double the size of the buffer or whatever, well, you know, that's going to fix that problem. Maybe you fix the overflow completely by testing the input. Okay, you don't need to test that over and over and over again and test all 15 different, you know, you get a 15 character limit. You don't want to test all 15 possibilities on it. If you wind up doing that, you wind up, in some cases, I've seen some commercial products out there where the regression test takes 3 weeks. You don't want to add 3 weeks to the release of a product every time you regression test. So when you're doing regression testing, make sure that you're doing it effectively and that you're testing the right things as opposed to just testing old bugs and things that have come up. Don't just go adding, oh, we found a bug, we're going to add that to our regression test. Microservices. According to Wiki, it's a variant of service-oriented architecture. Again, you're building services or small things that stand alone and can be called on or operate independently. They're small, they're a single function. You build them to facilitate automated testing. That's a key point there. You want to make sure you have some sort of a return that tells you whether or not it failed, and if it did fail, where it failed and what happened. They're elastic, that is, they're configurable, and you can go in and work on it without affecting other components. They're composable, again, one little piece, and it's complete, right? Each service is a complete piece on its own. How many here are doing things with microservices right now? Anybody playing with those? Okay, yeah, I figured you guys were. Again, it's a great way to build up little pieces at a time. You can add and subtract functions and service functionality if you want to. Very, very easy to work with. Continuous integration. According to AWS, this is where your developers are merging code changes into a central repository. How often do you guys do integration? Is it really continuous, or is it? Yeah. Sure, yeah, you check something in, and the minute you check it in, it gets built and gets put into the next integration. And that way, you know, you're going to know immediately if something's broken drastically and the build doesn't fail. And your phone's going to ring and people will say, hey, this build failed because of something you did. You're going to go, first of all, you're going to reverse it and check it back out and figure out what happened and fix that build, because you want that to keep happening for the next folks. It's got to be automated. It's got to be tested. Pass, fail. Very, very simple, very easy. Either build works or it doesn't. If it does, you move on to the next step. And if it passes, you're ready for continuous delivery. Continuous delivery, same thing, automatic build, test, and getting ready for production. You don't necessarily put it in production automatically, but you at least get it ready for production. Again, it's got to be automated, repeatable, pass, fail. It's part of a pipeline. And we'll talk about the difference between configuration and orchestration and automation and orchestration here in a couple of slides. In fact, coming up on the next slide here. Build automation, okay. Again, automatic tasks. You want to build something, your builds are automated. You go in, you say, okay, I've got a new piece of code. You add that to some list or some table or something, and now that piece of code is included in your build, and you know what's going to happen. You check it out, you compile it locally, you test it, and then you put it into the build process, and the build does the same thing. It's going to build, it's going to check it out, it's going to compile it. Any compilation errors, of course, you're going to immediately throw back at the developer and shoot them for that. But assuming it compiles, you're going to execute some tests, you summarize the results, and then pass those results back to the build owners and the other people involved. When I was at Microsoft back in the day, we used to have a build that ran overnight, and we had it literally building on all the machines in the company. You would go out and find an idle machine and set it up and get it work at compiling and building things. So you can do those kind of things with automation, and it really makes a huge difference. So the difference between automation and orchestration, release orchestration is the next piece, and we call that orchestration because orchestration is really about automating processes. Okay, you've got a release process that you go through that's going to include lots of different tasks, and the tasks may be automated. Those individual tasks you can automate with shell scripts or whatever you want to do that. But for orchestration, you're going to use a tool, something a little more complicated than that. Different vendors have different tools. I won't go into all of those that are out there now. There are a bunch of them that are out there that people are using. But orchestration can enable process optimization. Okay, you can look at a process and say, I've got duplicates here, or I've got something that's out of sync if I do it in a different order or something. Better may happen, and you can orchestrate a whole workflow. So automation is all about orchestrating about automating individual tasks, making individual tasks perform automatically. Orchestration is about taking a workflow, connecting those tasks, and running each task independently and going on from there. Release orchestration is a concept about using tools to manage releases, and it's pretty essential for continuous integration and continuous delivery. So if you're going to be integrating and doing it continuously, that is, every time somebody checks something in, you'd better have that process or that workflow really, really well orchestrated and well nailed down, so that you're not chasing failures in that process and having to chase failures and things happen there. Provisioning is all about preparing something, okay, building something and getting it ready for use. Okay, it might be a network, it might be switches. Usually these days it's going to be virtual. It doesn't have to be. You can provision hardware servers, hardware boxes. But it's not to be confused with configuration. Okay, provisioning says I stand up a server and I put an operating system on it. I connect it to a network. I don't necessarily give it an IP, but I physically connect it to a network and get all the bits and pieces together so somebody can come along and use that server and do something useful with it. Provisioning user, same thing. I add the user to my Active Directory or some places like that, but I don't necessarily give them security clearances or anything beyond a basic authentication. They're just provisioned and ready to be set up and made available for a specific use. Configuration is going to be the next step in that process. Again, back to an example of the large bank I used to work for. When we got there and started a group I was in back in the late 90s, we couldn't build the same server twice. We asked our contracting organization to build us a server. They'd build it, they'd set it up. It'd have one version of the OS or whatever happened, and then the next one you build tomorrow would have a slightly different version of the OS because somebody downloaded a different set of patches or done something different. Well, that can lead you into all sorts of problems. Again, a little war story here. We had a 4-node rack environment, and pretty straightforward. Same version of Oracle, same version of Red Hat. This was before OEL, so it was Red Hat, same version of Red Hat. Everything all set up for independent server. There were independent hardware boxes, except we had this one problem. You could fail any node in the cluster, and the other nodes would take over and figure out what's going on and keep running, except one node. If we failed one node, one particular node, if that one particular node failed, boom, the whole cluster is down. Everything's dead. Could not figure it out. Had Oracle in there, had Oracle fly somebody up from Redwood Shores. We got them on site. They played with it for about a week, couldn't figure it out. Again, this was before autonomous databases, before any of these kind of things. We finally got to the point where one of the DBAs got very frustrated, and he said, you know what, I'm going to go back to basics. So we took We took the whole cluster down, and he went down to single user on all the systems and said, okay, show me the pieces of firmware you've got, show me the network cards you've got, show me the hardware configuration, show me the database configuration. And he started doing a line-by-line comparison of all that. It took about 2 weeks to do that. And finally, on the fourth node, of course, fourth node he picked, what he discovered was that one of the network interfaces, the one that happened to be used for the heartbeat, was 2 dot releases down revved on the firmware and the network card. So network card was 2 releases back on the firmware. And that particular piece of firmware had a network bug that caused a race condition. And so if that was the node that got picked as the surviving node in the quorum, its network card went into a race condition and it never came back. So whole cluster's down. That's the kind of thing you want to avoid, and that's the kind of thing you can avoid with provisioning automation if you build your servers correctly and make sure you build the same server every time. And again, you got to go all the way down to the firmware. You know, just make sure that everything is identical when you're building clusters in that sort of environment. So configuration, the next step, configuration management. I already asked, everybody's got their initors and their P files and all those things and all your PL SQL under configuration management, right? Using Git or something like that to do that. I find that even at home, I've got a GitHub server at home that I use, and even keeping track of the code I have running around. If I don't do that, I'll get lost and something will get out of sync, and then I can't remember what change I made 6 months ago. You know, I work on a project and then I go away and I leave it for a year and then come back to it and it's, oh, what the hell did I do here? I'm sure you're all doing those same things. But, so configuration management is a must. You've just got to get that done and got to get configuration set up. It's all about managing changes, right? But it's also more than change management. You don't want to build change management processes that are so complicated and so involved that it takes 3 or 4 days or even a week to make a change in production, right? That's going to shoot the whole idea of DevOps right out the window. You don't want to wait that long. I've talked to some companies that change management processes are all actually automated. They're part of the continuous delivery process. When something gets ready to be delivered to production, the change management system that's built into the delivery process sends an email to the approvers, tells them what it was, summarizes the test results, shows what was going on, and they've got 15 minutes or an hour or 2 hours to respond, and they've got delegates if they're out of town or whatever. So they respond. If they don't respond, things start escalating and going up the chain, and that way they keep their change management processes running. But it's pretty rigorous. I mean, anybody can raise their hand and object and say, no, I don't want to make this change. So if you're 800 flowers, you don't make a change to your production system the weekend before Mother's Day, things like that. But you can do that, and you can still automate change management and make it go forward without having to make it so onerous that you don't get anything done. It's most often applied to software again. You want to build the same thing twice. Automatic versioning, figure out what version you're on. Always version everything. We had a situation in a large software vendor based in the Northwest that I won't mention by name, where we had a new version of the product come out, and they decided, oh, well, we'll just tack an A on the end of the version number because we don't want people to understand that this is a huge, big bug that we need to fix, and it was. A different story around that, but so they tacked an A on the end of the software version string, and it turns out they, in the process of doing that, uncovered a character limitation and a string overflow condition in the software that's in the code that displayed the version. And of course, that A overrode something that was very important, and we had yet another crash. So the next version was a full version number increment without the A on the end of it. And we fixed that first problem too. But those are the kind of things we can run into if you don't have good testing, and you don't do quality control and so on, and you try to sneak things past your change control in your versioning system. Difference reporting, look at the differences, see what they are, consider them. The company in Germany that uses some of Quest tools actually has a system set up where they rate the software and the change somebody makes that goes through their build process. First thing you do is run a diff. And if the diff comes back with more than, I think something like 20% of the code, they kick it back to the developer and they say, okay, this probably shouldn't be a change, it's going to be a new module, or you're going to do something different, or you have to justify it at least and get it approved before you go forward. So there's things you can do there and make sure you're not doing a lot of differences and you can't take a header and replace all the code underneath it. And again, automation is the key there. Canary release, something I've done myself and a lot of other people do. Kind of like a phased rollout. You can talk about it as a phased rollout. Deploy a new change to a subset of the users, right? You pick a subset, either maybe users that are using a particular feature or users that aren't using a particular feature, and you roll something out to them, and then you start looking at it and watching it very closely and seeing what's happening. You can also do some capacity evaluation that way. How many people here are still cloning full production databases for use in test environments? Anybody doing that? Okay, a few. Well, think about doing that in different ways. You know, you're going to run into some security issues, timing, performance, all those things. It's great to have production data, but you want to be a little careful about that. But this is a good Canary release is a good way to get around having to do that. You test with data that maybe is a few weeks older than production, or not quite production, or maybe it's obfuscated, or maybe it doesn't have certain data in it. But then you can do a Canary release to a small subset of users, do your capacity evaluations, and then figure out a quick no-go and do an easier rollback. Again, planning is the key to that. If you're going to do Canary releases, you want to make sure you can roll them back quickly, right? If you do a release and you can't go backwards, that ain't a Canary release. That's not going to be something you're going to want to do in a Canary type environment, because again, you can't roll it back, you can't fix it. But it's always better to be able to do that. And if you build your systems right with microservices and small pieces and things like that, and you're making small incremental changes, you can do that and pull things back without having to do that. And again, you're going to get consistent functionality. You want to make sure that you have consistency in your functionality, and all your pieces look the same, whether they're before or after what you're doing. Dark release, a lot like a Canary release. You don't tell anybody, right? Don't tell people you've made a new release, and that you usually deploy it again to a subset of the users. And again, planning is still key. You don't want to lose data if you have to roll back, and you want to keep consistent functionality. Now, you probably don't want to do something that's going to change your whole UI as a dark release, because you don't want to surprise your users with that. Anybody have that happen to them, where you're working on a product or working on a website, and all of a sudden, you know, today the website looks very different than it did yesterday? Yeah, that's not good. Don't want to do something like that. But anyway, a dark release is another way to test things, or to try capacity and get away from having to do full-blown big releases and make a big hoopla about it. So DBAs in the room, what's in it for us in terms of functionality and in terms of DevOps? Okay, well, what if we could monitor and identify performance issues throughout the DevOps pipeline? I've had a number of DBAs tell me that, you know, we're going to adapt some of this stuff. We're going to do that, even as simple as, I was at a conference a couple weeks ago in Texas, and the DBAs there at a large company were talking about saying, hey, you know, we're going to start doing this. We're going to set up our testing tool so that it does an explain plan. And if the cost is too high, we're going to kick it back and not let the developer proceed with it. And I talked to them a couple weeks later. I followed up with them, and they'd implemented that, and they were finding that their developers were, you know, pissed off at first, and what are you doing? Why are you doing this to us? But they did find out that they weren't getting any bad plans put into production anymore, because they stopped them before they went into production. So you can do those kind of things, and if you set up DevOps correctly, you can make that happen. How about developing and deploying higher quality database changes faster with application changes without compromising? Okay. A lot of times today, you make an application change, and because you can't test it completely, or because it involves a bunch of database changes, maybe, you know, you're changing, adding some columns to a table, doing some things in a database schema and configuration, and you've also got code changing in a database. Well, okay, it was tested. We'll just throw it into production and see what happens, and then you wind up with bugs, and you wind up with low quality, and bad things happen. And what if you could automatically replicate production changes in the near real-time environment to other database environments, right? You get your changes in one environment, you need to make them to another, you want to move your data to a different environment, and so on. And so here comes a commercial I told you about. We've got some tools for developers and DevOps that'll do that. Here's how we do that with the Quest tools. Now, there are other tools out there, and they're all equally good, but I'm from Quest, so you hear about all the Quest tools. We got Foglight, which is our database monitoring and performance tool, performance management tool. You can look at that. It's a great replacement for OEM, particularly if you're running on a standard edition or some other places. Toad for Oracle, everybody I'm sure is familiar with Toad. We've now got a DevOps toolkit that comes with Toad. We integrate Toad with DevOps and with DevOps testing, Jenkins, and a lot of the other tools that are out there, the source configuration management tools, Git, Team Foundation Services, all the configuration, SCM, and configuration management tools that are out there. You can use those and integrate that with Toad and build that into your DevOps pipeline. SharePlex for database replication and cross-platform replicate data between different pieces of platforms, Oracle to Postgres, Oracle to MySQL, Oracle to just about anywhere, and SQL Server to just about anywhere. And then Toad Data Point for migrating all the schemas and keeping things in place and doing all that. So here's a little note about what the environment kind of looks like. We've got the developers over here on the left using Toad Edge and Toad for Oracle, your source control system, your dev environment, Toad Edge and the tools for DevOps, Toad DevOps Toolkit lets us integrate with Jenkins and Bamboo and some of the other products to automate that testing and configuration process, get that all automated, monitor again with Foglight. We've got a couple of companies, the large bank that is using Foglight. They do a build, make some changes, detect the changes they've made to their code. They come in Foglight, they take a baseline in Foglight, they make their changes, they run another baseline, and they go back to using Foglight's compare capabilities and compare the before and after and make sure they got the improvement they decided they wanted, and also make sure they didn't break anything else along the way. So that's what happens, and that's how we use DevOps. And then once you get things in production and get out of staging, replicate it with SharePlex to any place else in the environment, clouds, or any place else you want to go in your environment. And that's the presentation. Anyone got any questions?